23 August 1799, in a letter to Dr. Tressler, William Blake wrote, "The tree which moves some to tears of joy is in the eyes of others only a green thing that stands in the way. Some see nature all ridicule and deformity, and by these I shall not regulate my proportions. And some scarce see nature at all. The eyes of the man of imagination, nature is imagination itself. As a man is, so he sees. As the eye is formed, such are its powers." In the discussion following last night's film showing, Ecology of Mind, about the life of Gregory Bateson, we talked about the fact that some people can't see the forest for the trees. But I think, harking back to last year's keynote presentation by Tom Munneke, perhaps we should rather say, which, by the way, discussed the difference between a cat and a toaster, for those of you who may remember that discussion. It's not so much that some people can't see the forest for the trees, as that they can't see the forest for the lumber. They don't even see the trees. We were in a discussion last night with some of my students who I know are beginning to understand organic order and complexity theory, and how some forms of organization simply will not do for highly complex systems, and others which we can learn by studying how nature manages its unbelievable levels of complexity into things that make so much sense, how we can model our own organizational systems upon that. And I know they're beginning to see it, but because they don't have the level of mastery that someone like a Tom Munneke does for seeing that kind of structure on the macroscopic scale, they think that maybe they're the people who can't see the forest for the trees. And that's why I thought this morning it was important to pause and say, no, you can't see the forest for the lumber or the toasters. It's that you look at the world and you see things, which, as Gregory Bateson taught us, are not actually there. There are relationships that are there, that everything is made of. The mechanistic worldview has the advantage that it's easily explained, easily put into a project plan, easily budgeted and contracted for, and that makes it seem, in an economy in which money equates to value, it makes them more successful in contracting. It makes it seem as though that worldview is the more mature, powerful one. The truth is that it's the naive, simplistic one, the mechanistic one, the one that sees the world as made of building blocks when it's not. The cosmos has layers of complexity to it, layers upon layers upon layers that relate to one another. Any complex system has to break into this kind of a layered structure of organization, and that is why, when Tom Munneke in the Underground was helping to structure the architecture of VISTA, he laid it out the same way. That is why we have the speaker we do this morning. That's why I'm going to have Tom Munneke introduce him, because he knows whereof he speaks when he talks about these issues that are so central to our ability to organize and manage the VISTA software lifecycle into the future. So everyone, Tom Munneke, round of applause, please.
Thank you. Yeah, this is a really exciting topic to me, and I think the theme here is architecture, and Michael will talk about just what is the built world, but we're building things here. We're not just adapting, fixing the plumbing, and fixing broken sewer pipes. We're building things, and there's an architectural vision to that. We had it early in the VISTA time. It's not quite as clear today where it is. Architecture is an abused term, I think. The architecture in Ocera really is a plumbing diagram, but it's not this vision of how our built world reacts with our users. So anyway, I had a wonderful dinner with Michael last night, and been talking actually previously about this. And he comes to us from the perspective of an urban planner and architect, and expert and a student of Christopher Alexander, which he'll explain. And you wonder, why is an urban planner going to talk to a Computer Geek conference? And he might be asking himself that also. He's listened to some of our things. But anyway, the format here is to give him time to talk about his work. If I see something, or if anybody else sees something that relates directly to VISTA, he's willing to interrupt and carry that through. We'll also have a session after this for those who are more into the architectural worldview, and we'll leave that, and we can do it that way. So anyway, here's Michael. Thank
you. Along the lines of what Tom said, I'd really like to make this more of a conversation. I know very little about VISTA, obviously, and about MUMPS, but I am very interested in having interdisciplinary conversations, because I think what we find out, and I found out in the discussion with Tom last night, is that all of us in many ways are solving the same kinds of problems. And when we compare notes with each other across disciplines and in different fields, we see those things and we learn from each other. We learn more important lessons from each other that we haven't seen ourselves because we're locked into our own sort of framework of looking at things. And I think Chris Alexander is probably a good example of somebody who has catalyzed a lot of discussion across different disciplines in a very interesting way, not just software, as you probably know, but other fields. And in many ways, ironically, it is we architects, I say with my background in architecture, who've been maybe some of the slowest in some ways to pick that up. But maybe that's the same challenge, that when you're in a discipline, you're sort of like fish in water. You don't see the water. And maybe that's part of the reason that Chris is a bit of a prophet without honor in the world of architecture. And the related thing is that he is quite critical of some of the things that we do in architecture. But what I don't want to do is just give a lecture on the nature of order. And as Tom was saying, what I'd really like to do is have more of a kind of conversation. So if there are things that you're, that I say that you say, wait a minute, what are you talking about? Please jump in and let's have a little more interaction, not just the sort of talking head mode. And if there's anything that you are struggling with, or that you, above all, I think, what does this mean in practical terms? I mean, we can talk about the philosophy, and that's very, very important. I also have a background in philosophy, and I do think as we think we live, what, you know, our philosophical point of view shapes our actions in profound ways, and we've got to get that right. But we've also got to, at the end of the day, ask, what does this mean in concrete terms for me and for my work and for the people that I work with? And so I'd love to help you and have a discussion with you about that. You all know, I'm sure, about Chris's work with pattern languages, which has been a very interesting, I think, cross-pollination and productive collaboration.
No, we don't.
You don't? Okay. People don't? Okay, well, I'll talk about that then. I'll talk about it a little bit later. Most everybody knows about design patterns, I assume? Not necessarily? Okay. Well, good. Then we'll talk. Let me just start out with this point. We're all designers, but bad design can kill, right? We all know that. If you do a medical system that's badly designed, you can kill. If I design a bad hospital, it can kill. And design that fails to understand the problem it seeks to solve is likely to be bad design. And Tom talked about the difference between toasters and cats last year, right? If I confuse the problem I'm solving as a toaster problem and it's actually a cat problem, I'm going to have a bad design. So, and if I see the world as only a kind of mechanical problem, which is the problem that Chris set for himself in the nature of order, I'm going to have a problem. When in fact, it may be, you know, technology is not simply, we think of technology as just this, right? It's just a sort of mechanical way of understanding the world. When in fact, this is technology. The way we make things, the way we make our world. And what is it that we're trying to achieve with technology? I would submit to you that we're trying to achieve a quality of life that has a kind of beauty to it, a sense of connection to other people, connection to our work and to our world, and that ultimately this is what technology is all about, what we're trying to achieve with technology. So when Chris talks about the nature of order in this book, you know, we might wonder, well, what the heck is he talking about, order? A lot of architects wonder about that and say, you know, order is something very regimented and top-down, right? Well, in fact, what the sciences of about the last, you know, the Nazi order, right, very militaristic and regimented, but in fact, the science of the last half century or so has demonstrated to us very clearly kinds of order, classes of order that are emergent, that are self-organizing, autocatalytic, and so on. And we're learning a lot about that, not just in terms of, sort of the lessons for paying attention to the forest as well as paying attention to the trees. But I would suggest to you, more importantly, how those two things relate to each other, how we can be very precise in understanding how to catalyze that kind of bottom-up order. And that's really what I think Chris is talking about and what a lot of other people are talking about. Ward Cunningham, who you will probably all know his work, well, you should, because he's the guy who invented Wiki. But not just Wiki, he developed the design pattern movement, which is, I'll talk about a little bit in more detail later. But he noted, and this is a discussion between Ward and Tom, last October, I think. And Tom was asking Ward about his approach and how he thought about the problem that he was trying to solve. And he said what he found exciting was that this language-like capacity that we humans have, that we can generate many different kinds of expressions out of the same fairly simple grammatical rules. And that the rules aren't that complex. They can be quite simple and quite robust, and yet they are very powerful if you have the right rules and the right kind of linguistic structures. And so the question that Ward asked was, why don't we do everything that way today? What's the problem that we have that makes everything so seemingly overcomplicated and difficult and challenging? And the answer that Ward said was, well, pretty much we did do things that way until we got over-specialized professionals looking at each problem in isolation, and more than that, trying to decompose each problem into what they thought was simpler and simpler. And they said, oh no, we can just simplify with some very simple sorts of reduction, processes of reduction. But the result of that was that they actually made it much more complex. They complicated the world overall by creating that very specialized set of simple ideas. And what they didn't understand, as Ward was pointing out, was how some systems of rules can generate behaviors instead of specifying behaviors. And I think that's one of the key things I'd like to focus on today, in fact, and maybe that's how this could be useful in terms of VISTA and other ways of solving the problems that you folks are dealing with right now. How can you distill down the key elements that can work together in this kind of grammatical generative system to produce the behaviors that you really want to produce? And this is what I'll try to explore. So this notion of generating instead of specifying is something we see all over in biological systems, what we're learning now about the genome and about the sort of the way that these structures are generated through fairly simple kinds of almost origami-like folding and transformations and so on that generate these very, very complex and very robust kinds of forms, as opposed to what we've been doing, which is specifying every little detail, doing the blueprint as, it's as if we were trying to create a human thumb by drawing a little blueprint of the thumb. Here's where the nail goes, and here's where and so on. And of course, nature doesn't do that at all, and it would be crazy if nature did. So perhaps we need to take a clue from that. And that is really what, do folks know Agile? Does people know? Okay, well, Agile grew very much out of the same spirit that Ward worked with in design patterns and in his other work with developing Wiki, which was really a way of collaborating on design patterns. The Agile Manifesto is quite short, as you probably know, but it really is in the same spirit of what are the sort of key things that we need to identify in terms of the interactions and the individuals who are going to carry those interactions out. And then the design patterns movement, which is, I understand some are familiar and some aren't, but it's a ubiquitous system now that's used in the Cocoa language and in most games and in the Mac OS system. So if you've got an iPhone, you've got it. If you've got a my computer here has design patterns, and that's based upon pattern languages. Ward Cunningham and Kent Beck, back in the 80s, were struggling with ways to create more language-like approaches to software, to put it simply. And this is really what Ward was describing to Tom when he was in the quote I just showed you. And Chris Alexander had developed pattern languages back in the 1970s as a language-like way of designing. And I'll talk in a little bit more detail about that later. But what's interesting about it is that it has become very influential. If you Google pattern language, you'll see about 500,000 hits. That's a very respectable number. But if you Google design patterns, you get 10 million hits, over an order of magnitude, about 20-to-1 ratio. So that's an interesting point. What's going on there? Why are design patterns in the computer world so much more prominent, at least on a Google search? And in fact, I mentioned that they're involved in many games. The Sims, Will Wright has been a big proponent of design patterns and pattern languages. Wiki was a direct outgrowth of that. I mentioned the iPhone and the Mac computer and so on. So there's a couple of interesting points to this. One is that this does show that there is a fruitful collaboration to be had between our communities. The other thing I think it shows is that there is a kind of language-like approach to coding, to designing, that can be very fruitful. And so exploring that in a little bit more detail. I mentioned that it's not just in software that pattern languages have become influential, but in many other fields, in sociology and biology, many other. I'm just going to flash through these very quickly. You can Google and see lots. There's some very funny ones. Pattern language for wedding, pattern language for pattern writing. That's an interesting sort of self-organizing system, I suppose. And then for sustainability, and then that one, which I love, I'm not even going to try to say that. Somebody will have to explain what that one means. This one is very interesting. This is a couple of molecular biologists who are looking at a kind of pattern language model, which they developed more or less in parallel with Chris, not really inspired by his work, but that it's a way of understanding how multicellular organisms actually evolved. And that's a kind of a mind-blowing idea that there's some language-like process going on that's responsible for that. I think in software coding, that's a pretty exciting idea. So you have this big domain of pattern languages, design patterns, and so on, especially in software, maybe not quite so big in other domains. And then you have a much smaller domain in architecture. So in the actual field where this discipline evolved. So what's going on there? Well, I think it's actually a very interesting and important observation that tells us something about how architecture is done today and how maybe a lot of other design is done today. It takes us back to this field in philosophy, this word that's not used anymore, Mariology, which is simply part-whole relations. What is the relationship between the parts and the wholes of any given structure, whether it's a technological structure, a design, a natural structure, anything that you want to talk about. It turns out that there's a lot that we can say about that as logicians and philosophers and technologists. And there are some things that we can bring to the discussion, especially now in our current age, when we're dealing with economies of standardization and replication and scale, which have been very, very fruitful. There's no denying that. And yet we've also neglected other kinds of economies of differentiation, adaptation, and economies of place, which are starting to look a lot more important than we realized before. And that's a question that I'll pose to you in terms of software design. What could that possibly mean? Well, I think it could possibly mean something to do with generating behaviors instead of specifying behaviors. and what that might mean. Most of you know, I'm sure, that some sort of revolution has been going on in mathematics, in physics, in biology, in a lot of fields, in understanding complex systems and how they can be generated from incredibly simple sets of rules, like the way bird flocks self-organize and the way lots of things in natural systems follow very simple rules and then generate these incredibly complex patterns as a result of that, cellular automata, as they call them, and so on. And we're now seeing lots and lots of places in natural morphology and natural phenomena where this is going on all the time. The fractal algorithm, if you probably know, is incredibly simple. It actually is just a kind of an iterative cycle that looks at the current pixel and then applies a formula to essentially all the previous pixels and generates that pattern. It would be a mathematical formula that would describe that pattern rather than generating that pattern would be as complex as the system itself, so it would be useless, essentially. So that's an incredibly important insight, and we're seeing the same thing in genetic processes and starting to see some pretty exciting and tantalizing ways of understanding how these generative processes actually go on, as I said before, kind of like origami-like processes. And that doesn't mean that they're not understandable. It just means they're understandable through a different kind of process rather than the sort of blueprint process I was talking about before. And in fact, when you look at human processes, cultural processes, they do a lot of the same kinds of things. We can turn around and look at similar kinds of generative processes, including in culture and art and lots of human endeavors that are very fractal-like, very generative in the same kind of way, and generate these kinds of, and of course fractal patterns can have this kind of traditional-looking, beautiful, carpet-like quality to them. And what I'll just emphasize again is that this is a structural phenomenon that we're beginning to tease out pretty accurately, especially now in the cybernetic age when we're dealing with our own complex systems, the systems that we ourselves are generating when we make computers and software and technology and cities and all of these other things. And the great polymath Herbert Simon, who I hope you all know. If you don't, I would encourage you to read up on him a little bit, wrote this paper in 1962 called The Architecture of Complexity. And the point that he noted was that these complex systems do have a roughly hierarchical structure, but they are nearly decomposable. And it turns out that the near part of that is very, very important. And that was very much echoed by Jane Jacobs, another great polymath and independent scholar, remarkable person in many ways, urban scholar, economist, design theorist in many ways too, and beginning to be taken much more seriously within those disciplines, and has really played a profound role in urban planning. And she made a point in the last chapter of this fantastic book that I would encourage you to read, Death and Life of Great American Cities, quoting a guy named Warren Weaver, who was one of the pioneers of complexity science. And remember, this is the 1950s. She says, we're really beginning to see the world in a different way. We're understanding, we have new scientific models that can tease out these problems that you call organized complexity, which have taken us from the sort of mastery of two variable problems through algebraic and different kinds of two variable equations into the sort of statistical world of many, many variables, but you don't need to know how they're interacting, you just need to know how they're behaving as statistical populations. And we sort of skipped over this middle realm, as she called it, which she called the problems of organized complexity, where it's not the number of variables, but it's how they're interacting and how they're organizing into patterns that's much more important. And that's where, again, when Herbert Simon is talking about nearly decomposable hierarchies, Chris Alexander was thinking along exactly the same lines as a PhD student at Harvard. What is it about nearly decomposable that's important in understanding how these structures evolve? and how we can take advantage of that. Well, Chris began to think more about these interrelating patterns, this near decomposability, which he called overlap. And he began to recognize that in identifying those patterns or those diagrammatic relationships, you could identify clusters that are essentially more or less object-oriented pieces of information about the relationship between those parts. And that originally he called those diagrams, later on he called them patterns. And what was important about that was that you could abstract those patterns, those clusters, and you could then identify rule-based relationships between them, and then you could recombine them. And that was an incredibly powerful idea because it gave you a methodology to create simplicity within the complexity that you were dealing with. That wasn't just the rigid hierarchical approach, the sort of top-down, everything has to be lined up, in a row. Rather, we could have a much more flexible, interconnected kind of web of relationships in our designs. And that's what the pattern language, the system that he developed, actually allowed you to do, to identify particular clusters of design, which would be very language-like, entrance room, house for one person, and so on. And in fact, the point that he made was that we already do something like this, or have done something like this. We've done it in language. Our language isn't just a series of hierarchical lists where like a grocery list where, you say, first do this, and then part of that is this, and then part of that is this. Instead, what we have is something more like poetry, where we have a web of relationships between the different elements, and we structure those relationships, and we manage those structures in important ways all the time. And we've done that in our design work as well. So his first book on this was Notes on the Synthesis of Form. Again, asking this question, what is the relationship of the parts of a problem to its whole? What is this question of Mariology? How does it work? How does it work in nature? How does it work in our own human technology? And what might be different about that? What can we learn from that relationship, and particularly from the new insights in this cybernetic age? And again, looking back at earlier cultures, he sees a stark contrast with what we've been doing, particularly in the 20th century, where we take a form that is built out of preconceived categories, essentially the top-down hierarchical model, and recognizing that those do not really fit the problem. They cannot fit the problem, and the result is a kind of arbitrariness in the design, a willfulness, as he says, and a lack of understanding of the real nature of the problem that needs to be solved and is not being solved, and that plagues the design of modern buildings and modern cities. Pretty damning indictment of my architecture colleagues who didn't always appreciate it. And so again, in Notes on the Synthesis of Form, he looked at these hierarchical relationships, and he looked more importantly at the clusters that formed within those which were useful. And so if we can do that, he thought, it would be an important strategy forward to identify these subsystems of the adaptive process, as he called it, and treating them as subproblems and combining them in a language-like way. This is the essence of pattern languages, and really the essence of Chris's work ever since, to a certain degree. Chris wrote a critical paper of urban planning in 1965 called A City is Not a Tree. Funny title, but I think you can begin to see what he was getting at, that we've been planning our cities in very tree-like relationships where, here's the center of the town, and here's the neighborhood, and here's the streets, and so on. Very rigid and very, very constrained in comparison to the way natural cities form with these overlapping relationships between the parts. And the argument that he made was that these are essential. They are inherent in the nature of good cities and good adaptive problem solving. And he gives a simple example. I won't spend a lot of time on this, but just of 3 parts. In Berkeley, there's a traffic signal with a pedestrian crossing, there's a newspaper rack, and there's a drugstore. And those three things operate as a kind of a, you might think, a rock, paper, scissors relationship between them, right? You can't organize them into a hierarchical relationship where one is at the top of that. And so what he says is this is really a major restriction on the capacity of our structures to do important things. It's as if we had members of a family who were not free to make friends outside of the family unless the entire family made friends with another entire family. And you can readily see how constraining that would be. And more importantly, these overlaps, this near decomposability, is not a defect of the structure. In fact, it's the essence of this kind of resilience of the structure, this thicker, tougher, more subtle and more complex view of structure, as he says, and that gives us resilience and gives us redundancy and ambiguity and all the things that we think of. And again, this is an echo of Jacobs and the notion that we're beginning to recognize why we have been failing in the way we've been making cities and failing to understand these important relationships. Because again, we've been thinking of the problem as very simple sort of hierarchical or two variable or statistical kinds of problems instead of problems of interconnected relationships. This notion of a web network, I'll touch on the importance of networks in a moment in our design thinking and how we can take advantage of those. And the notion of a linear system where you proceed from one step to the next, or the variables are related in some linear process, to a self-structuring, mutually adaptive system where all the parts are interacting with each other according to some rule-based process. And as a result of that, they can self-organize. They can serve as cellular automata and interact with each other. You don't have to command them into a serial kind of order. And of course, we're recognizing more and more that ecological problems have this characteristic. Many technological problems that we haven't been solving, like climate change and others, have this kind of characteristic. Lots of problems, not all problems. There are places where the linear models are very effective, but they're not enough by themselves. And this notion of networks and the closely related idea of self-organization, I think, is really important. From a designer's point of view, maybe from a software designer's point of view, is the idea that if you get the right elements together, you can let the thing proceed and organize itself. This was the idea behind Wikipedia, of course, is that you just get the structure right and then you let all the other participants self-organize it. The other key point is that it's a network structure, and it's not just any kind of network structure. There's a lot going on right now that's very interesting in network theory and mathematics and other fields. And I'll just touch on that. I don't want to get into it deeply, but maybe it's interesting for some people who might want to explore it further, or maybe already know a lot about it and find it very interesting. But there are what are called small world networks. There's certain kinds of networks that can self-organize if you get them right. And there's some work going on now called rich club networks. And there's certain kinds of, and it comes from the idea that the old boys are in the rich club, right? And it's who you know and so on. Well, that's turns out to be the way a lot of networks actually do behave. And what you want to know is what are those nodes of the relationship and what are the connections between them, not necessarily people with power and money, but places where there are resources within the system that you want to know. And so there's a couple of very interesting aspects of this that I'll only touch on now. One is that if you know the right kinds of motifs, which maybe could be software motifs, I don't know, we could explore that, then you can use those to allow it to self-generate much more complex kinds of structures. You don't have to design the whole structure yourself. You just have to know how the network is going to behave and whether it's going to have the behavior that you want it to have in the end. The other thing is that it's scale free, which means that you can start small and you can let it grow into something much, much larger. You don't have to start at the scale of the entire US healthcare system, let's say. You can maybe start in a very small place, and if you have the ability for the system to grow, then it can proceed, and it can do that very, very quickly, actually, and can cut through a lot of inefficiency as a result. So we're learning a lot about this. We're learning also, I'll just share with you a little bit about, in my world, what we're learning about energy and carbon emissions and greenhouse gas emissions and things like that, and economic development. And all those things are closely related. Jane Jacobs talked about something called knowledge externalities or knowledge spillovers. And what that means is that cities are kind of like metabolic systems that bring people together to share information and interact with each other in a network pattern. And as a result of that network pattern, we can generate new kinds of knowledge, new kinds of industry, new kinds of economic activity, which is why cities become these powerful economic engines that they are. It's why New York was such an efficient engine for taking, penniless immigrants from around the world and as an input, and outputting, middle-class doctors and musicians and writers and people who are incredibly creative and productive in all kinds of ways. So this knowledge of how this happens, what's the dynamic, and how can we as planners do smart things to encourage that and not do dumb things that prevent that and that waste energy and that burn lots of resources. We're learning a lot about that right now. It's very exciting and very intriguing when we look at, for example, energy use and carbon emissions and how much more efficient cities are per capita than other areas. And it's not just that, well, everything is closer together, which we can understand that. It's also in the connected pattern of relationships. So I think the more we understand about these connective patterns and their sort of metabolic characteristics, the more we have tools at our disposal to take advantage of that and to make more efficient designs, more efficient urban planning tools, more efficient software, more efficient strategies. I'll just show you briefly. I want to check on the time because I don't want to take too long here. But this is a street in London near where I used to live. And what's interesting about it, if you look carefully, it's a self-organizing network of spaces that human beings use and regulate in certain kinds of ways. If you just look carefully, you'll see there's some people on the sidewalk, there's some people sitting in that little cafe, there's some people inside there looking out, there's some people behind that hedge, there's some people up on the balcony. These are all room-like spaces that people are using, and they have the ability to regulate their degree of privacy and publicness through the doors and the windows and the curtains and the gates and all the other things. But more importantly than that, they're interconnected with each other through this network relationship of sight and sound and movement, and those things are able to be regulated and self-organized by the actions that people take in opening their windows or moving their chairs around or whatever they're doing. And this fits, again, very closely with what Jacobs was talking about cities as these kinds of mechanisms of interactivity and connection, and that all does come down to the sidewalk and the place where people interact with each other through these different kinds of spatial connections to one another. And that, again, the mistake we've been making, and she was writing this in 1959, and unfortunately the same thing could be true today, was that we're creating the same kind of template-based, top-down approach to making cities that has failed in the past, and we're continuing to make the same kinds of mistakes in building cities that are incredibly inefficient, incredibly resource consumptive, don't add very much to quality of life, create lots of unintended consequences, and I think we all recognize the sort of fragmented, encapsulated, disconnected way that we've been making cities that is incredibly inefficient and requires lots and lots of energy and resources input to sustain that, and therefore it's not sustainable. And yet, this is the rationally engineered solution if you think about it from the purely sort of disconnected atomic level. Well, I need my house and I need my office and I need to get between them, and this is how I connect, you know, the sort of most quote-unquote efficient path between the two. But in fact, it's a false kind of efficiency. It's a very inefficient pattern in the end. You can't take mechanically additive elements and think that because they're logical in themselves, that it will create more logical structures at higher levels. And I'll give you a couple of funny examples. If you live in an auto-dependent community, how do you walk the dog? Maybe you drive the dog.
Yeah.
If you live in an auto-dependent community where you can't walk and the only way you can get exercise is to go to use the Stairmaster, and you go to the mall, and the mall is very kindly providing the escalator to get up to the level where the Stairmaster is, you're taking the escalator to the Stairmaster. This is from my friend Dick Jackson, by the way. He's really great. He's a public health official down at UCLA, a great guy. Anyway, and this is the point is that these things in and of themselves seem logical, seem rational, and yet together they are complete absurdities, as you see. And this is unfortunately what we do all the time as designers. We create structures that are in and of themselves rational and logical, and that as you combine them, you know, I want to have my car and be on the road and drive as easily as I can, and that's great if there's nobody else on the road, right? But the next person wants to do that too, and the next person, and the next person, and the next person. So suddenly I'm sitting in a traffic jam, not getting where I want to go, emitting lots of carbon and causing all kinds of problems. So I think what we are recognizing, especially in urban planning, and I think in other disciplines too, again, this is the conversation I'd like to have, is we are reassessing what we mean by growth. Growth is not simply the quantitative, it is the qualitative as well. Growth in biological systems is not something necessarily ugly or destructive. And in both cases, in the case of, let's see, did I get the right? Yeah. In the case of urban planning and maybe bad urban planning, disconnected, fragmented, sprawling urban planning, there is stepwise growth according to rules and processes. So we need to understand that there is generativity going on. It's just generativity by bad rules, right? Segregated use zoning, remote design processes that aren't paying attention to what's really going on, bank lending rules, traffic engineering, all the other things. And yet, in biological systems, you have the same kind of stepwise growth according to rules and processes, but they're more adaptive, they're more responsive to the selection pressures of the environment and all the other things, or else they will be extinguished very quickly, and maybe we're threatened with the same kind of challenge on another level. So we have to understand, I think, that there is a role for this adaptive feedback that we're not getting in our current approach. And there's a role for for differentiation, for allowing the structure to go on and to fit itself, which is very different from this kind of template-based approach that we've been taking, which is effective in its own way, but in a very limited way. We've gotten a lot of mileage out of that trick. We've gotten a lot of quantity and not a lot of quality necessarily. But the response by some technologists would be to say, yeah, but come on, you've got to be realistic. You've got to deal with the problem of large numbers. Well, nature actually deals with the problem of large numbers pretty darn well, you notice. and lots of other problems along the way. So there are economies of scale, but also economies of adaptation and economies of place in these biological kinds of processes. And there's something inherent in the morphology of the structures that we find very beautiful. And that, we were talking about this last night, the idea that beauty is not just some sort of aesthetic trick that we pull off right at the end by sprinkling some magical beauty dust on it. It's inherent in the structure that we're looking at, inherent in the way it grows and the way we feel the form as a pattern and as a kind of set of relationships. And the notion of growth as transformation over time, which is what I'll get into when I talk about Chris's work a little more. Again, in human processes, we can see lots of examples of growth that everybody finds very, almost universally beautiful and desirable, and yet it's the same kinds of transformation, stepwise over time, adaptive, iterative, growing. Even in humble places like slums, there's a lot of this that goes on, this autocatalytic, self-organizing growth. This is a slum in Jamaica that's very, very poor and lots of social problems, and yet there's something going on there that's very, very interesting, the way these places are self-organizing. I was working in New Orleans after Hurricane Katrina, and we saw a lot of the same thing, a lot of very beautiful evolutionary kinds of structures and patterns that were incredibly well adapted, exquisitely well adapted to the problem of living well, living in a salubrious way, in a way that connects you to your neighbors and to the quality of life that you have there. And yet we saw lots of very, very dumb things there. There was the disaster of Katrina, but there was also the disaster before Katrina. The way we had been sort of erasing all of that kind of adaptive growth and creating this, again, very highly over-regulated hierarchical kinds of growth, again, creating all of these unintended consequences. And unfortunately, this is in Houston, by the way, this is and not to pick on McDonald's, but just to say if that's sort of an indicator species, if you will, of a very encapsulated car-centric kind of engineering model. We're doing that right around the world. This is in Brazil, China, India, and Eastern Europe. And there are McDonald's and lots of other similar kinds of structures that are adapted to this mechanical model of growth that is consuming way more resources. And anybody who just looks at the numbers, forget about whether you're, a quote-unquote environmentalist. If you're just a hard-nosed economist and looking at the numbers out 10, 15, 20, 30 years, you begin to recognize that we're in big trouble if we don't change the way we do things, not to mention the other challenges that are beginning to come home to roost, like carbon emissions and climate change. So when we've got all of these challenges, all these massive process difficulties, as we were talking earlier, what kinds of approaches could help us cut through that challenge? And I think pattern languages are aimed squarely at that kind of challenge of beginning to understand how to work with networks, how to design through a kind of object-oriented approach to design, including software, but other things too, so that we have the capacity to not only create this web-like set of relationships, but allow it to create itself, in a sense, allow it to evolve within larger social networks and larger collaborative frameworks. And if we have time, I really want to touch on the work that Ward Cunningham has been doing with another kind of wiki that is incorporating patterns into it. But I want to leave a little bit of time for certainly for questions and answers. So on that note, let me return to a couple of more specific ideas about the nature of order. I've got a couple of, it's a huge book, and I've got a couple of volumes of it here if anybody wants to peruse it, but I'll just give you a summary of some of the key ideas. And it really arose because Chris recognized some remaining issues with the pattern language approach and with the book in particular. And one of them was simply that the book only had 253 patterns, and you need thousands and thousands of patterns. As in the design patterns world, there are surely millions of patterns. It was hard to interface with conventional systems and methods, and most importantly, there wasn't enough information about the process that generates form and what that form was in terms of the overall structure of a particular kind of design rather than very generic kind of design. So that's what the nature of order was really aimed at, saying, let's look at these questions and let's look at how something might be operationalized. So the first question is, how does nature achieve this kind of emergent order that we see everywhere around us, and what can we learn about that? Well, the first thing to recognize is the point I made earlier, that nature does not make little blueprints. It doesn't specify behaviors. It generates behaviors, as Ward said. It makes something more like recipes or coded processes for growing form. And the results of that are emergent and self-organizing. And I mentioned the genetic process, the cellular automata, fractal processes, and so on. So that's the first sort of insight that the book is based upon. Then there's some other key ideas that I'll just go through quickly as kind of hopefully tantalizing you, and we can maybe discuss them more. Many of you probably know about the concept of symmetry breaking in physics. It's the notion that you don't simply, and again this goes to Mariology, you don't simply place different elements of structure together and combine them. You take a structure and you break the symmetry of that structure through some kind of interruption or disruption, and that in turn generates new structures. And so this is a profoundly important sort of generative process that goes on all the time in nature. Might have even been the original mechanism of the Big Bang, for example, and the structure of everything around us. A simple example of that is this famous sequence by Harold Edgerton of a milk drop hitting a sheet of milk. And the symmetry of the sphere is, and in this case it's a physical symmetry, but it could be other kinds of symmetry. It's shattered as soon as it hits that plane, but it doesn't turn into a chaotic mess. It turns into another whole series of very intricate, amazingly detailed structures, a whole series of other rings and arm-like appendages and just a marvelously ordered kind of structure that just spontaneously emerged from that symmetry breaking, ordered for free, as Stu Kaufman calls it. And then closely related to that is the idea of differentiation. That again, as you see the sphere breaking and shattering, it differentiates into all these other structures around it, which is exactly what happens in the process of embryogenesis, where a simple structure will differentiate into multiple structures, limb-like appendages. And you see this kind of limb-like structure on the lower right there. And then again, this notion that this process has a lot to do with the way language works. There's similar kinds of structural transformations going on. And the notion that in language, we are really, in essence, capturing a structural process that's going on all the time in nature. And we can capture that through our words, through our models of what's going on, and the sort of symmetries that we find that are useful to us. And then we can transform them, and that gives us, in turn, our own sort of generative power to generate structures, to be creative, to be poetic and artistic, and so on and so forth. And these structures are not simply quantitative elements brought into some kind of configuration. They are inherently qualitative. And I think a lot of people in a lot of disciplines are recognizing now that we have to take on the qualitative dimension of things. In neuroscience, for example, or in cognitive psychology, or in certainly environmental psychology, and many other places, you simply can't ignore the qualitative dimension. You have to at least deal with it as a kind of a peripheral phenomenon, and maybe it's even more important. We're beginning to see as a sort of understanding of what's really going on from an empirical point of view. As the philosopher Alfred North Whitehead pointed out, what we experience as facts are in fact value laden from the very beginning. Matter is only matter because it matters. And who was it talking about? Yeah, the idea that it was Bateson was talking about the idea that what we experience as hardness is because it's the result of a contest, right, between our hand and the thing. And that's a qualitative experience as well as a quantitative one. And then another idea that results closely related to that is the idea that we can't deal with the world as being simply a dead place in which these somehow strange living phenomena occur, that life itself has to be seen as a kind of pervasive phenomenon within the structure of everything we see in order to make sense of this world around us. And again, this is an idea closely related to Whitehead's work. The idea that nature is in some sense alive, and questions are, how is that living structure ordered and organized, and how can we make use of that? And that order is a kind of wholeness, a kind of not simply collection of parts, but a way that all the parts relate to each other in a structural way that gives it the life. And going back to Tom's idea of the toaster and the cat, you can, no matter what you do with the parts of the toaster, you're not going to create living structure. On the other hand, if you take genetic processes and organize them in a certain way, as geneticists are now doing, creating new cells from proteins and so on, quite interesting, amazing stuff, you can create living structure. And so this is a notion of, philosophically speaking, of structuralism, the idea that we're dealing with structures in the world, we're confronting those and manipulating those and transforming them in useful ways. And those structures are, if you like, the sort of embedded reality of nature that we are confronting, or at least from our own point of view, kind of a structural realism, which is related to, but also very distinct from, the sort of post-structuralist idea that we're only creating language and nothing else is real, and therefore we can create narratives about the world that reify our world. I won't get into the complexities of that other than to say that there's a scientific structuralism or a natural structuralism that is somewhat critical of that position and simply says we need to get on with it. We need to get on with recognizing that we have bodies, we have living processes, we can destroy those or enhance those, and we've got to get on with that. It's not just a matter of telling stories to each other. Another notion that Chris talks about is the idea of centers, which are closely related to the idea of patterns. And in geometric terms, in terms of urban planning, you can begin to see that centers are these sort of pattern-like structures that bring together systems of elements, parts into wholes, if you will. And we can begin to see that they're all interrelated with each other. They're all part of larger wholes and smaller wholes. Again, this sort of hierarchical, partly hierarchical, but also overlapping set of relationships that Chris has always been describing. And I think the same is probably true for software. That in a sense, software is also structural. It's structural even in space, I would argue, because it does exist somewhere. It might exist in our neurons, it might exist on the page, it might exist in the circuits of a computer, but it does exist in space. So there is this reality of physical centers. And I'll kind of skip through this because I don't want to spend a whole lot of time on this part of the talk, but I'll just show you an example, a physical example of centers as being something that we recognize as having a lot to do with living structure and the quality of structure when it's alive. And this is the actress Penelope Cruz. You just take a piece of somebody's face and you can begin to see these distinct parts that relate to each other in a very closely embedded kind of a way that are in fact centers, and they are part of larger wholes and smaller wholes, and all of these things are very, very intimately related to each other in a complex way, and then the whole thing is mirrored on the other side of the face, and so on and so forth. And we are very good, it turns out, at recognizing that. We apparently have parts of our brains that do nothing but recognize faces and recognize these kinds of center patterns. And if you begin to take those away, you begin to see what it does to the sense of life of the structure. It becomes a very dead, doll-like structure that is just very disturbing, right? And yet, and it is in this structure that we perceive those holes and that beauty and that sense of something that's alive, which indeed it is in this case. And so that's an important idea to understand. What is it about these structures that might tell us something about how these centers form? Well, they form through transformations that preserve the structure as it goes along. So if I looked at Penelope Cruz's face when she was a child, it would look pretty similar to this, but it would have transformed over time to her face now. And that's the sort of thing that goes on all the time as well. And again, you see the transformation here through this symmetry breaking, and you see the new kinds of centers with new geometric properties and new kinds of relationships. And it turns out, this is a really surprising result that Chris got in thinking about this, that he could classify all of these kinds of geometric relationships in 15 different classes. And he called them 15 transformations, and then the results of them are 15 properties. And there are things like levels of scale, so you have large things and small things that are related to each other. You have boundaries, you have strong centers like the big circle in the middle, you have local symmetries, the smaller parts relating to each other in symmetrical ways, alternating repetition, and so on. And he categorized those, and he was actually sort of working phenomenologically, was able to go through and just figure out, and I won't go through all these in detail, but how to describe in terms of these 15 classes all the different kinds of structure that you see. And that's useful to know, because not only can you see how these structures emerge as a process through this sort of morphogenetic symmetry breaking kind of process, and which is useful to see when you're looking at how structures evolve in natural systems. We can also, and then we can also see, by the way, how they emerge through a lot of human activities and have for many centuries, and through the kind of architecture that we all find very beautiful and very moving in many cases. These kinds of, again, these same kinds of geometric relationships that he's talking about. And we can also see some very different kinds of geometric relationships in the architecture that we've been producing over the last century or so, which is based upon, not upon those 15 categories, but upon a much smaller subset of them, and upon particular geometric configurations that are not transformed, but simply stamped down, or maybe transformed in a sort of a superficial way. And a lot of architects are agonizing about this. Rem Koolhaas talking about you can't transform quantity into quality through abstraction and repetition. Absolutely true. That's been a failure and a hoax, as he says. And he says that this has been a fiasco. It's finished. We have a massive crater in our understanding of modernity and modernization. At the same time, Koolhaas, who is more of a post-structuralist, says, well, there's nothing we can do about it because we're not in control and these forces are more powerful than us, and so on and so forth. Alexander says that's nonsense. We are in control because we just simply need to understand the nature of the problem as we haven't up till now. We need to recognize that there is a sequence of steps. We can recognize that sequence of steps, and this needs to begin by recognizing the initial conditions as a whole. We need to recognize what the sort of genetic material of that is, what are the resources that will allow it to grow through a kind of diagnostic process, very closely related to medical processes. And it's a qualitative. evaluation. The doctor, when you walk into the room, doesn't just start hitting you with a battery of tests. The doctor often says, how do you feel? He begins with a qualitative, he or she begins with a qualitative question and qualitative diagnosis. And these characteristics are really real. If you feel sick, you really are sick. You're not just telling a story about being sick that you decided to tell because it's your culture or something. And these things are shareable, and they're part of our culture. We have freedom within that culture, but it's within the structure of our natural environment. And so this in turn suggests that there is a kind of structural approach we can take. And this is where maybe I could suggest to you guys, if you have ideas about how this could translate into software, that it's possible to create a kind of operating system that would generate these kinds of form, that would rely upon a more generative kind of code, that would not be parametric, would not simply specify the results, but would be more like a rule-based genetic process. And for those of you who were at the film last night, there's a lot of symmetries, a lot of similarities to what Bateson talks about, and I already mentioned Whitehead and Jacobs and Simon and a whole bunch of folks who are waking up to these problems, Stuart Kaufman, the others at Santa Fe Institute and many, many other places, many other disciplines, recognizing that we need new cognitive tools, we need new ways of thinking about our problems and structuring them, and this notion of beauty as a notion that is not simply a sugarcoating of what we're experiencing. It's not simply an amenity that we can live without or live with. It's actually an intrinsic characteristic of what we're experiencing that we have evolved in a very sophisticated way to be able to pick up so that we can promote our own well-being and the well-being of the people around us. And I think when you're talking about medical care, that certainly has to be central to the notion of what we're doing. And this notion that Jane Jacobs talked about the web way of thinking as opposed to the thing theory, as you were saying, that it's fine to talk shorthand about things occasionally, but if we get stuck at that level of things and fail to understand the interrelational aspects of design, we're going to be in big, big trouble as we are. So the notion of a pattern language in Chris's earlier work was more about patterns of form. The notion of generative codes is more about patterns of process, a kind of design-build process or a bootstrap process where maybe if you're talking about software, you're talking about a system that you don't try to code everything ahead of time. You just code a few rules and then you let the thing evolve. And I think certainly that was the spirit of Wiki, which is a very simple kind of system. But it had the charm and the beauty that people would jump in and flesh it out and do lots more for that. And I'm going to flip through some of this stuff because I want to end on a note for discussion. One is, of course, what can we learn from different disciplines? What can we learn from what's already happened in the kind of interaction, the cross-pollination between software designers and architects, and especially in Chris's work, and all of the other things that have happened, but also other fields, economics, psychology, biology, many other fields that are dealing with similar kinds of issues. And this is maybe what we can talk about in terms of, well, how could this relate to software? Perhaps talking about structure preserving transformations means start with what you have, don't discard it, maybe simplify it, get rid of a lot of the clutter, but don't just throw it away and start over necessarily. Symmetry breaking means don't look for ways to add something totally new, look for ways to crack what's already there, to sort of split it up into smaller problems and create new sort of differentiated structures. Centers and patterns, maybe we need to identify the key leverage points, the sort of agile kernels, if you will, that will catalyze the kind of self-organization that our clients can do. Maybe we do less and they do more, but we do less in a smarter way. And facilitating those more like the way gardeners facilitate the growth of a garden rather than carpenters facilitating that kind of growth. And then just to close on this, and maybe we can discuss this a little bit, the board's current work, as some of you may know, and if you don't know, it's pretty exciting, I think. He's doing a new generation of Wiki, which is much more based upon the ability to manage numbers and complex formulas in this very simple page-based, pattern-based kind of way. He's using JSON to do that, and it has some amazing advantages over, say, a spreadsheet kind of approach or something like that, where you have a spreadsheet and one cell will break the whole damn spreadsheet if you got something wrong, right? So this is a more object-oriented way of managing data, managing patterns. And in this case, this is a Nike system where they're handling metrics of sustainability, like water usage and energy usage and so on. And you can, a designer can model the scenarios and say, well, let's try this polyester fabric instead of the cotton fabric, and let's see what the result is in terms of water usage and cost and carbon emissions and all these other things. And very quickly recognize what the benefits are of this different scenario. Very quickly test scenarios and different kinds of design alternative paths. So I think you can begin to see from that, there's lots of other applications, and I'm working with Ward now on urban design, where we can look at the metrics there and the things like how many people are living in a town center, how many households, how many people per household, what's the tax revenue of that, what's the carbon emissions of that, and all of these kind of quantitative issues that are tied to the qualitative issues. So you can begin to structure these things into these web-like relationships and understand the consequences of them. So I think this is a good example of how these insights, which may sound very abstract and philosophical and okay, so what? That's the forest. Where are the trees? Well, these are the trees, I think. These are the practical benefits that we can take forward and begin to see how these things might actually begin to generate more integrated, resilient kinds of designs, whether it's, and there's several different experiments here that we've done where we're looking at carbon modeling and economic performance modeling and so on, and looking at performance of things like a bike system, a bike network, how you would build a bike network in a city that doesn't have one currently. Here's one, I'll end on this one. This is a hospital design wiki that incorporates a lot of the sort of biophilic elements that we now know from evidence-based research are promoting of good outcomes, better outcomes for patients. Things like single bed rooms that minimize the spread of pathogens, view to nature, which lowers blood pressure and does all kinds of good things, having gardens and so on and so forth. So you're able to put these things together and you're able to begin to model the kinds of synergies that you get when you do that, which is pretty exciting, I think, pretty promising. So I'll leave on that note. Questions on, I hit you with a lot of material, intentionally so. Do you want to? Well, I do, because and again, what do we have, 10 minutes, something like that? Okay, first of all, if there's anything that anybody wants to just clarify or ask about, but, yeah.
One of the things you talked about is the sense of place, and you asked how does that tie into computers. One of the traditional ways of analyzing computers is to analyze how much time a particular program takes versus how much space it takes. But there's also a different kind of space analysis, which comes about by the fact that you've got this static listing that actually corresponds to this very dynamic thing called a trace. Mm-hmm. So it's like every line that gets executed appears in the trace. So if you've got a loop that does something 15 times, In the trace, it shows up 15 times. In the program, it only shows up once. So that's, that's relevant to this concept of how does space and space awareness and architecture of space tie in to programming and the architecture of how you write your programs and make them interact with each other.
Is that similar to the concept of elegance, would you say?
I'm sure that when you have a huge trace and it corresponds to only a simple listing, then yes, I would say that's an issue of elegance. You're getting a lot of power out of just a very small amount of program code to generate it that way.
A lot of people talk about beauty in their profession. I was struck when I was studying logic, and logicians were talking about beautiful proofs, right? And they mean something very structural, right? And they're not just saying, well, they're not just applying a metaphor. They mean it's beautiful to them. So the idea that beauty is a kind of qualitative reaction we have to a structure that has some meaning to us, has some value to us, I think is really kind of transcends all these other.
I'd like to try, you were asking, questions about some clarification. I'd like to try to understand a little bit, if you could, about the beauty of these couple of slides you put up with this new Wiki thing.
Which slides?
Which one? The one that's up there now?
Oh, the beauty of.
Yes, you see, so this is beautiful to me, but it's beautiful to me because I'm assuming that there's some, assuming that this is not just something that is crafted, for things and pasted on together. There's some structure, that there's something behind, that these four things have something in common. In other words, they're all derived from the same set of graphs behind, in other words, so could you comment on the underlying pattern that generated those four views or representation of the problem being addressed?
Can I answer that, Michael?
Yeah.
I think what he's showing there is actually Ward's new idea of what a wiki is, and these panels here are partly private, partly public, and so instead of a single page that everybody edits, you have this a much more dynamic way of handling your own pages and then federating them into a single display.
It uses the Git convention, if you're familiar with that, where you can fork it and then you can work on the whole. So you're not just working on the parts, you're working on the whole. And that's, again, this Mariology thing. But I think, going back to your point, there's levels of encountering of something that's beautiful, right? And at first, something that might look beautiful, you spend more time with it and it looks ugly because you've gotten deeper into the structure of it, like a person who's got a lot of makeup on or something, and they look maybe beautiful from far away until you get close or something like that. So I don't think, I think there's the whole question of what is it that we find beautiful and why, and there are lots of layers of that. But the idea that there's a structural fitness to what's there that we find meaningful in our own lives for some reason. And what I was going to show was the book Pattern Language, which, just a copy of it here, or a page or two, which the authors, they put photos of each pattern in when they were doing the book, and there was some debate about how important that was and whether it was really going to be misleading because there were particular details of that pattern and so on and so forth, or that photo rather. And it turns out that ended up being really, really important because it conveyed a lot of tacit information. And it was important in the sense that it was beautiful because it gave you the sense of beauty of being in that web of relationships that was not only structurally described as, a series of abstract nodes, but qualitatively presented to you. So it was qualitative and quantitative together, and that was beautiful.
Yeah. I think that combination is exactly, the thing as presented in one view, and then the underlying structure that it reveals. And then that combination one time is beautiful, and then it really gets beautiful when you see from that same structure another view,
Right.
which is also beautiful. And so what I'm intuiting, and I don't know if it's actually there, but I'm intuiting these 4 views of an underlying structure that's associated, and you know, each with a different utility, different level of audience, or different objective, but all derived from an interrelated structure. And you know, I think that's incredibly relevant to the work we're doing, the software at VISTA, and solutions that we need to be exploring more explicitly in terms of our work. So yeah, that's.
I agree, and I think, you know, in the notion of product design, the idea that the beauty is not just a veneer. You know, it's inherent in the design and in the simplicity of the design. I think Apple's done a pretty darn good job with that, sort of tying the aesthetics to the simplicity of the design and the usefulness of it. I think, unfortunately, in architectural design, the aesthetics, not only has the aesthetics been abstracted and kind of commodified, it's happened in a strange and I think kind of very dangerous way, which is that it's become treated as a separate fine art. That the architecture, quote unquote, is really an avant-garde fine art, and that's what's really important, and all the other stuff is there, but it's not really what's architecture. And I think that's been a terribly destructive idea, along with a lot of others in technology and in society, and it's served the sort of narrow interest of industrial production to have this sort of, you know, commodified architecture, iconic buildings, and all the rest of it.
Widget-based.
Sorry?
Widget-based design.
Yeah.
Right, yeah. Where the widgets are not derived, in fact, from the structure that you're going to
Right,
create, but are the generic kit of
Right,
widgets that
right.
you're going to pull over and make something pretty.
It's kind of gimmick based.
It's a gimmick.
It's like we were talking earlier about you can have a sign to a business that is quite ugly, and people, it doesn't matter so much necessarily that it's ugly. It matters that it gets people's attention. You know, like an obnoxious commercial or something, right? And so we've got, along with all the other problems we've got, I think we've got a series of sort of perverse incentives going on that are operating in their own narrow realm very effectively, but overall degrading our quality of life, and not just our quality of life experience, but our integrity as a culture, our intelligence as a culture, which is a very scary thought. We can't really afford this kind of stupidity when we've got the challenges we've got, right?
Last night, Tom brought up the Conway's law, and trying to apply this to software development, it seems that instead of focusing on how to design and architect software, we should be focusing, or we could be focusing on designing and architecturing the community that generates the software.
Absolutely.
Instead of going to the strict details of this should be here, this should be here, we could look at what are the skills and the background and the relationships between those software developers and their users. And just by creating that environment, software will happen, as opposed to us having to.
It goes back to the start with the whole. You know, start with not just the piece that you're working on, but the whole context, and diagnose that, and understand. You know, diagnose not just in the pathological sense of what's wrong, but what are your assets? What is your capacity to do things that you didn't think you could do?
A lot of VISTA was developed by programmers in relationship with a point of care person. And so the agileness of it was very high at that point. And within the VA, we've had an attempt to separate them and keep them as far away from each other as possible, and to freeze all change. And you can't do that in a biological system. I was a biologist before I was a programmer. And that's the surest way to kill something, is to try and have it stay in stasis.
Well, this is when you're trying to deal with toasters, instead of cats. And if you use toaster-like methods, you're going to kill cats, right? I mean, you can't treat that problem in that way, and yet we've got a sort of, bureaucratic methodology that's doing exactly that, that's strangling our intelligence, our capacity to solve our problems, and that's a very scary thing. Jane Jacobs' last book, by the way, was on that subject, and it was not a particularly cheerful, dark age ahead.
Is coming. At the next session, I think what I'd like to do is take his ideas related to VISTA and kind of do a mind meld between what he was talking about and the many, many topics, more specifically to the current and future generation of VISTA next S-stage evolution. And so that's what I think will be able to kind of firm things up a little bit more.
There was one person in the back that had a chance. Yeah.
Art and the Zen and the art of motorcycle maintenance looks very much at these issues.
Right.
On a Chautauqua, ironically.
Yeah, that was Robert Fiersig, Zen in the Art of Motorcycle Maintenance. He talks about quality as being a fundamental characteristic that we've got to bring back into the discussion, or else we're really missing something essential, obviously.
Yeah, I think some of this speaks to this drive they have to separate business rules into something separate, because what if they change? If they're all over here separately, then we can just change them, right? But maybe they're the DNA that tell the system how it should work. So doesn't that have to be inside of the system? It can't be divorced. You can't divorce the why something is the way it is from the thing. That's a real problem.
Right, and sometimes, I mean, it's not an obvious thing that there's good DNA and bad DNA, right? I mean, it's all contextual. So you can start with something that in a particular context is a negative thing, and by changing something else, it becomes positive, or vice versa. So it's I think it emphasizes the point that you've got to look at the context when you're dealing with these kinds of diagnostic processes. Right?
Trying to preserve context.
Thank you. Why don't we wait for half an hour?
Half-hour break?